See how we utilize time. બરાબર ને ફલક?
ફલક ને ટાઈમ મોંઘો કર્યો.
Okay. Potential energy due to multiple charges. થઈ ગયું ને? Okay. And we did an example. 2.4 and 2.4. 2.3. Okay. Now we will not be able to do 2.5. Exercise. Come on, go to the exercise, everyone. And when you give an assignment for capacitors, આ chapter માં છે capacitors. Okay, but it has a separate assignment because there are many questions to be done. Okay, now in the exercise we have done 12, yes or no?
Yes.
13 remains, correct? So 13 is homework. Question 13 is homework. 14 A is homework, B optional. करो तो कर दो, no करो तो मान लो. Okay, 14A, because 14B has very long calculation. અઘરું નથી, ખાલી આવું ઘણું બધું નંબર જેવા ખતરનાક છે. Okay, 14A is homework, B is optional. Do it if you like, otherwise it's fine. Okay, now fine, that's it. Now you can jump. 18 A. 18A is homework. Okay, but I just need to give you one hint about it. Let me explain what is meaning of electron volt. Okay, or EV for short. We have had covered the value in 11 that 1 EV is equal to 1.6 into 10 raised to minus 19 joule. Right? Probably in chapter 6 or somewhere we have studied. But how exactly is 1 EV equal to this? That's what I will tell you. Okay, so in that question 18A, you have to give answer not in joule but in EV. So this converting will take place, right? Okay? Fine. So you make sure you remember this. Now how do we get this? What is the meaning of electron volt? Do you remember earlier we have written that if you accelerate a charged particle, do you remember? It gains kinetic energy. That kinetic energy that it gains by accelerating a charged particle is delta K equal to minus Q into delta V. Basically this is minus delta. Minus delta U. Delta U is Q delta. Okay, that's because of the conservative nature of the force. Now, so if we accelerate electrons by a potential difference of 1 volt. What that means is, suppose electron accelerates between 2 points. Let's say one point has potential 0 volt and another point has potential 1 volt, then the electron will actually accelerate from here to there. It will go from 0 volt to 1 volt. Actually any values would do because value of potential is not important. I can make this 100 and I can make this 100 at once. Still gives the same one. Is that okay or not okay? Yes. Right? Okay. Now you might have a question like, why does electron go from 100 to 101 or from 0 to 1? Why not opposite? The reason is, more detailed reason will come a little bit later. Right now, let me just tell you. Have we studied this morning itself that electric field lines are from higher potential to lower? Electric field will be towards left side. Did you understand? From high potential to lower. So force on electron will be towards which side? Understood? Why it will accelerate from 100 volt to 1012? Yes or no? Okay, so this is the electron volts definition. That when we accelerate electron by potential difference of 1 volt, the kinetic energy it gains is called 1 eV. Okay, and it gauge is called 1 eV. એમાં કઈ નથી આમાં વેલ્યુ મૂકી આવી છે. Delta K equal to minus. What's the charge of the electron? Minus E. And delta V, look at this. Delta V. Delta V means this is initial and this is final, right? So final volt, final potential minus initial, the one other. Did you understand this definition and this equation? Minus minus plus 1 eV. Okay. I know E is not a unit here, but when we combine E with volt, it becomes a unit, right? So this is 1 E. But in joule, this same thing would be 1.6 into 10 raised to minus 19 joule. I hope you get why. Because if you put charge of electron, how much is the charge of electron? This much. And coulomb into volt gives you joule. That's it. Volt is nothing but 1 joule per coulomb. Remember that? Everyone? 1 volt is 1 joule per coulomb. So if you use it reverse, coulomb into volt becomes 1 joule. So that way you get it. Right? So this is the definition if you want. But that's it, right? So this is exactly how we get this conversion and proof. Yeah, okay. It's very important actually, not just for this chapter, but the later one. Okay? In chapter 2, in the last 4 chapters, in book 2, in the last 4 chapters, we will be using this EV very often, right? Okay, fine. I'm raising it down. Main thing for everyone is learning how to convert. Definition एक बार भूली जाए तो चलते, conversion भूली जाए तो नहीं चलता. Okay. Okay. Now, electric potential energy. Is this visible in the camera?
Yes.
This E? No.
Yes, yes.
So this arrow is not the real thing, right?
देखा ही है.
Can you read it then?
Yes.
So electric potential energy of multiple charges placed inside external field. Electric potential energy of multiple charges placed inside external electric field. So let's say that earlier we have studied that suppose you've got some charges here, let's say Q1 and Q2, or maybe Q0, right? Any number of charges, doesn't matter. Suppose this point is A, this point is B, and this point is C. Then we have learned that if there are only 3 charges, then the potential energy can be easily given as U12 plus U13 plus U23. Okay or not okay?
Yes.
What's new here? They are placed inside external electrode. So now, suppose that in all this region, there is some electric field. Is it uniform? No, doesn't have to be. What we are going to discuss works even if it is uniform or even if it is not uniform. Anything. So this is the potential energy mutually for these 3. Okay. But now what we have is that they interact not only with each other. That is, Q1 will apply force on Q2. Yes or no? That's why there will be a potential energy term between them. Q1 will apply force on Q3. So there is a potential energy term between them. Similarly, 2 will apply force on 3. That's why there is a potential energy term. Are there any other forces? Are there any other forces? Yes. Electric field will apply force on first charge. So there will be one potential energy term that will be indicating the relation or interaction of one, that is Q1, with the electric field. Is that clear or not clear? Right? Similarly, will 2 get a force from electric field? Yes. Will 3 get a force from electric field? be very frank, no, books don't write it like this, but you can think of it this way. That in this system or in this configuration, you have four things. Big one. Q1, Q2, Q3, and then the external electric field, which is not created by this or this, right? It is created by something else. It is created by something else. Then how many things are there in this? The four things should have 6 pairs. 6 pairs. Clear or not? 6 pairs. Have 1 with 2, 1 with 3. Okay. But then 1 with E. Because that also applies force on it. Understood?
Yes.
Sure, you're getting what I'm saying? Then 2 with 3 as usual. And then 2 with E. Because electric field also applies force on vector. Understood or not? Sure? Okay, so this line I am writing just for you. Okay, you do not write it anywhere in exam. Okay, this is a very simple way to understand what's going on. Just think that we are taking all the entities or all the things pairwise, but there are 4 things. I hope you understand what I am saying. Not 3, there are 4. 3 charges and 1 electric field. Got it? Okay. But how to write it? Suppose you want to write for exam, let's say this topic exam, let's say explain or derive the potential energy for multiple charges inside external field. Then you can just write it as this, that the potential energy in this case is the sum of mutual potential energy of charges and the potential energy of each charge due to external electric field. This sentence says it all. So what have we written? The potential energy in this case is the sum that is addition of mutual potential energy of charges. What means of mutual? Between two. Is that okay? Mutual means some relation between the two. So between two charges, means which charge is 1 and 2, 1 and 3, 2 and 3, as many as there are. And then something more. What more? And the potential energy of each charge, first charge, second, third, all due to the external. That are these 3 terms. But frankly, in not a single book you are going to see something like this written. Okay, I think this is my own way of expressing it, but this is a fairly simple. This will help you realize that okay, it's just like what we have said earlier. There's nothing new now. Okay, just take pair 1, 2, 1, 3 like that, and 1 E. Fine. Now, so U is equal to. There's no trouble at all with 1, 2, and 3. Okay, I'm just leaving this blank. 1, 2, and 3. These fine. आधी क्वाड्रेटिक पढ़े थे. It's got for say. What to write? K Q1 Q2 by R12 blah blah blah. Okay, fine. So that's done. This plus this plus this. Okay. Done. What about the next thing? That's what I'm interested in. So how do you write potential energy of a charge with electric? See, electric field is not a point charge. In fact, electric field is not even a charge. Yes or no? If there were 2 point charges, it would just like K Q1 Q2 by R. But electric field is not even a charge. So pretty simple. Every electric field creates potential. Yes or no? Every electric field creates potential. And if you have a charge at some point, okay, then you can find the potential energy of that charge like this. Clear or not clear? What relation have I used? U is equal to Q into V. U is equal to Q into V. Where what is V? VA means potential at this point. Created by what? Created by the external electric field, not by these charges. કે માનો ગણાય પોટેન્શિયલ તો અહીંયા બધા ક્રિએટ કરે ને સુપરપોઝિશન પ્રિન્સિપલ. Then why are we not including these two? Because that effect is already included here. Do you remember derivation of potential energy of two charges? The shorter method. How did we do it? We were just writing that this is equal to Q1 into V due to 2. Do you remember?
Yes.
So our potential already counts the unit. Easy one. Did you understand what I am saying? The potential due to the second charge at this point is already included in the first term. So there is no need. External or other charges, everything behaves in the same way. If you think about it, right? Anyway, so we don't need to include this. We don't need to include this. Is it fine? Okay, we just use VA. What is VA? VA is the potential created by external. Got it or not? Other charges નું નહીં લેવાનું કારણ કે already આમાં આવી ગયું. Fine. Plus what next? What do you think we should have? U2 VB. Clear or not?
Yes.
Plus U3 VC. Got that? Again, when you find VB, don't find potential due to other charges. Just find it due to external field. Where VA, VB, and VC are potentials at A, B, and C. Due to what? Due to external field. That's it. Easy check. Everything is pairwise. That's it. And just remember, see, along with this, let me give you another piece of advice. It's definitely very useful. Telling is sitting on the left side. Our line lagta nahi ho koi dekhe exam. Okay? Because nobody writes like this. So now I think it is very important to point out that, okay, first I'll ask you a question, then I'll build up the idea. Coulomb's law. Coulomb's law allows you to find what? Coulomb's law allows you to find force between point charges. Yes or no?
Yes.
Fine. But suppose you want to find force between two things or two charges, and suppose they are not point charges. So, anyone? Suppose you want to find force between two things. Let's say you want to find force between a sheet of charge, for example, and one point charge. What would you do? Can you use Coulomb's law? No, correct? Correct. No, that's right. But those who can't hear it, Coulomb's law nahi karana ke khud padi gayi. How to find force between these two?
Point.
F equal to very good. So I think I mentioned this earlier. It's worth repeating that wherever Coulomb's law does not work, this will work for you. Correct or not?
Yes.
If you put a charge Q inside some electric field E, then the force on it will be Q into E. So what will we do? Okay, here's the charge. It is placed inside electric field created by the other one. Yes or no?
Yes.
Sure.
Yes.
So we'll find electric field due to sheet, for example, and put the charge in it and find the force. Method clear? Method clear or not clear? Sure? याद रहते ना हमें पहला की तो जवाब बुलाओ ना जरा. Okay, this is an important concept that whenever you want to find force on a charge, you can use this relation. Okay, but Coulomb's law is only valid if there are 2 point charges. In other situations, you have to depend on this. So the steps would be as follows: find E first, okay, done. Then put the charge over there and find the force. Got it? 2 steps clear? Okay. Fine. Just like this. Suppose I tell you that we have 2 point charges and we want to find potential energy, then I'm sure you'll happily say, sir, K Q1 Q2 by R. But what if they are not point charges? What if they are not point charges? What if there is some other type of charge? Let's say you want there's a charged wire, okay, and there's a point charge. How is it work? Raise your hand. How will you find the potentiality of this system of charges? So many of you were trying. Come on, I would say no to come out. Okay, very good. Yes. Right formula? Very good. That's good thing. Find V first of all. Due to what? Not due to this. Due to this. Okay, so here at this point we'll find V first. Okay or not? We have a very strong, very powerful formula to find V at any point, and that is ગમે તે હોય એટલે આ તો થશે. બીજું કંઈ થાય કે is that clear? So this way you can find V due to the other term. And now you bring that charge and put it here. So now if you want to find potentiality, then U will be equal to Q. Do you see similarities between these?
Yes.
The force. And નીચે છે potential energy. Clear? Yeah, there is aware. Then whenever you are given some other kind of charges, then obviously Coulomb's law won't work. What to do in that case? You do this. Okay, our question textbook માં એકાદ છે. Okay, right? It's actually related to this. I hope you are seeing. Yes or no? Okay, but you might get this kind of question in Delhi. Right? Suppose there is a line chart like this and this is a resistance R, and we move it from here to here. Find the work done. Find the work done by the electric field, or find the external work done, or whatever. So, is that correct? Is that clear? Delta U. But to find delta U, you need formula. Yes or no? And now we know that. Or basically, you have to do some kind of integration. Without that and without this, you will not. Okay, fine. Okay. Alright. So remember this piece of advice. Well, example 5. I know many of you have the question, sir, formula તો આવડે છે પણ ક્યાં શું કરવાનું ને એ ખબર નથી પડતી અને પછી ખોટી જગ્યાએ થઈ જાય. Right? Okay. Number 5. Determine electrostatic potential energy of a system consisting of two charges. 7 microcoulomb minus 2 microcoulomb with no external field placed at minus 9,0,0 in centimeter and 9,0,0 in centimeter respectively. Draw the diagram. Do it fast. Call them Q1 and Q2. So it's easy to talk about. Alright, so two charges are given. There are two charges, and what do we have to find? What do we have to find? Potential energy. Possibly the easiest question in the world, or not easy? શું કરવાનું? U equal to K Q1 Q2 by R. Okay. Charges are given.
Yes.
What is R in this formula? When you try to use it, what will be R? 18 centimeter. 9 no મૂકી દેતા ભૂલથી. 18 into 10 raised to minus 2, because R stands for the distance between the two charges. Alright? So part A is done. What's the answer? Finish. The answer is minus 0.7 joule. Yes or no? Into 10 raised to minus 2. 9 to the 18. What can you measure? Answer those. Okay, I hope everyone has done. Why are you all using pencil? I don't understand. Pencil કરવાનો બુક બગડે એમાં કઈ વાંધો નહીં ભલે બગડતી ઉડાડી દેવાનું ખોટું પડે ઓકે શું થયું ફેન બંધ કરવાનું કે ઠંડી લાગે એસી બંધ કરી દેતો ઇવન બેટર આ ફેન તો બંધ જ છે ગરમી થશે એસી બંધ કરો Okay. All right. So the answer is 0.7 joule. 0.7 joule. Minus 0.7 joule. Minus 0.7. मारे देव mistake no करो. Okay. B part now. What does it say? What's the B part? How much work is required to separate the charges infinitely away from each other? So right now they are at 18 centimeter distance. You have to push them away and put them at how much distance? Infinite distance. Right. So which work is to be found? Work done by electric field or external work? External work. Required to be done. This is a clear sign that this is external. Clear? Okay, આમાં તો કોઈ confusion નથી. But as always with external work, I have told you that the faster you move the charges, the more external work is to be done. Clear? આમાં એવું કંઈ કીધું નથી. Only about requirement. So we will do it slowly. આમ તો બધી વખતે almost એવું થાય. But yes, it is not a rule. Sometimes as an ODT, you will get a question where it will be given that here it has this speed and here it has a different speed. Find external work. Okay, don't take it slowly over there, otherwise you will not get the answer. So here, because it's slowly, we get it clear, and that means it is equal to delta U, and that means it is equal to UF minus U1. Okay. What can you say about final potential energy? Zero. How do you know? Did you take them to infinite? Okay, then put very good zero. Clear? Clear or not clear? Yes. એકદમ easy હતો ને આ તો. Now part C. This is 7 microcoulomb then and minus 2 microcoulomb. Okay, this is at 9, x equal to minus 9, and this is at x equal to plus 9. Okay, here is origin between them. Find out ne? Okay, right. What's the question? C. Suppose that the same system of charges is now placed in an external electric field. I want a topic. Okay, right? Now there is suppose an external electric field everywhere. How much? A into 1 by r square, where A's value is given. So let's write it. So we know that here everywhere in this region, the electric field, external electric field is A upon r square. What is it? 9.
Coulomb.
Okay. So an appropriate SI unit. This is the electric. Fine. Now what do we have to find out? What is the potential energy or electricity potential of the configuration? Yeah, means this whole. So now here, how many things are there in the system? 3 now. 3. Is that here? 3. 3. And 1. Got it? Everybody?
Yes.
Okay. Okay, they got it. Of charges with each other, and then every charge with electric field, or basically pairwise. Everything we have made paired. But to find that, if you remember, we need to find V, potentials. Let's say this point is A and this point is B. So we need to find what is VA, we need to find what is VB. Clear or not clear? Everyone, because first charge is at A, second charge is at B. Right. Also, let's call this Q1. Again, like I said, that is easy to talk about. So what is VE? Potential at 2. Now, here. Do you realize that this is just like KQ by R square? Yes or no? Some constant of 1 R square. There is only one problem though. In question, it is not mentioned. You have to measure distance R from which point. Is it fine? So we'll have to write a sentence over there in the question. So there is a little mistake in the question. Write it. Write that R is to be measured from origin. R is to be measured from origin. Understood what I said? R is to be measured from origin. Fine. Now, you can prove this as well, but here we can use a lot of intuition, make it very simple. If electric field of something is like this, proportional to 1 by r square and all that, then do you realize that the potential at any point should be like this? Yes. Electric field due to point charge. I know electric field due to point charge. How much is that? KQ by r square. Okay, so your potential KQ by r. No change in numerator. This is electric field for point charge. Then potential due to point charge is KQ by r. So what changes? KQ constants. No change here. Only 1 by r square becomes 1 by r. Did you understand what I am saying? Okay, I will leave it pattern here. Sure. So if this is electric field, then what do you expect potential to be? A by r. Yes or no? Clear? Yes. Can we derive it? Yes. કરવું હોય તો જેને કરવું હોય બધા પ્રાંજળ નથી. How integration કરી નાખજો. શું કર્યું? ફોર પડી ને કે ન ખબર પડી? V potential is always integration of minus integration of E vector dot vector. એવું કર્યું. So if you do all that, obviously 1 by r square integration will become minus 1 by r. એટલે minus plus થઈ જાય ને a by r આવી જશે. But there is really no need to give it. Easy છે એમને કરો ને તો કમ અઘરું. right? Comparison easily tells us that if electric field is kq by r square on this type, then the potential will be a by r. So now can we find VA and VB easily? How much will be VA and VB? What's the distance from origin? 9 centimeter on either side. Yes or no?
Yes.
What is how much body is it?
Yes.
Very nice. Clear? Why we are writing a by r only? Just think of this. Numerator not change. Denominator becomes r. If you go from electric field to potential. A by r square. A by r. Chalo. A's value 9 into 10 raised to 5 divided by r's value how much? How much is r's value? 0.09. 98. 9. Very good. Because distance is to be measured from origin. Equation में आपे लोग है. Research तो कम ही answer. Okay. Understood this step? A by r. Both are at same distance. Okay. Both are at same distance. Clear? So what's cancelled? And this is 10 raised to 7. Okay. Now time to find potential. U is equal. U of 1 with 2 plus Q1 VA plus Q2 VB. Clear or not?
Yes.
Hidden step U is equal to U12 plus U1E plus U2E.
Yes.
Okay. So what is U12? U12 is U1E is Q1. Clear or not? Because first term, where is it put? At point A. So Q1 VA. Got it?
Yes.
Sure. The topic that we learned, we are using it here. Fine.
Yes.
Then second one, Q2. And where is it put? At D. So Q2 is. Okay. Do we already have this value?
Yes.
I will find it. U12 is minus 0.7. Okay. Then Q1. What's Q1? 7 into 10 raised to minus 6. VA is 10 raised to 7. Plus Q2 is minus 2 into 10 raised to minus 6. And VB is also 10 raised to 7. Everything clear? This. Right. So this is minus 0.7 plus 0.7. No, sorry. Plus 70 and minus 20. So final answer is 50 minus 49. That's your final. Ready? Okay. As usual, as it has been in 12th standard so far. Once you understand the concept, some other going to just put the values. Like here, we already learned this. Correct this one. That if you have got multiple charges inside external electric field, you find the potential energy like this. Okay?
Yes.
We just put all the values. That's it. Right? Have they minus 9 plus 9 पर लेके अलग एक कोई तो याद है ना? You just have to change the value of potential. Correct? And if distance is changing, then accordingly. Right? Okay. So that's it about that particular section. Okay. Now let's go to the next topic. That is potential. Potential energy of order follow good perspective. So we will now study electric potential due to or dipole. Short step. Electric potential due to or dipole. That बिल्कुल तो नहीं था पर ठीक है okay so let's say that there is a short dipole here थोड़ा diagram नीचे draw कर लो ऊपर space ले okay so because we are going to draw it over there and here center of the dipole let's say this point is A, this point is B, So as usual, these distances are A. Dipole moment will be towards which side? Left side, right side. Dipole moment will be towards which side? Left side or right side? Right side. From negative charge towards the positive. Is that okay? Suppose there is a point P here, which is very far. Basically, we are talking about a case where it's a short dipole, or you can say R is much bigger than A. Okay, R. Clear? Suppose the distance of C from P is. Now, on the side, I am drawing a little diagram here. P hat is in this direction and R vector, if I call it a vector, is in this direction. Angle between them is theta. Correct or not?
Yes.
Do you see that angle here? Do you see the angle here? Theta.
Yes.
Fine. Everyone get that? We are interested in finding what's the potential at the point P because of these two charges. Okay. So when there are multiple charges, how do you find potential at a point? By superposition principle.
Yes.
Find potential due to first charge over here, then find potential due to second charge over here, and add them. They are not even vectors, isn't it? Potential is a scalar, so come through easy. Correct or not?
Yes.
But there is just one term, a distance. It's not R. The distance is not R. So we have to find the distance first. The mota bhagnu derivation emerges. And frankly, the Book's method is very obvious. Right? If we would have had the liberty to replace Book's method by something totally different, I would never teach you by this way. Alright? But you, for example, the book ma je રીતે derivation આપ્યો હોય, we generally have to do it that. Yeah, you can do minor changes, but it's not like you do a completely different method. Okay? Fine. Minor changes તો થવાના છે. મેં કે book ના step કોને યાદ રહે? Right? કે આમાં પછી આમ કર્યું, આમ પછી આમ કર્યું. બોલ કાઈ કે? Okay. Let's find out distance. So first of all, you can write it in words. What to write? Let there be a dipole with charges plus q and minus q with dipole moment p vector. Okay, p equal to 2a q and blah 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 blah. Okay, consider a point p. Point p is at distance r from c, right? Such that CP makes angle theta with dipole moment, such that CP makes angle theta with the dipole moment. Clear so far? Or not clear? R is much greater than A. You figure match lagi na ko ચાલ. અલગથી પહેલા આનો લગ એના અલગ પડે. Let's find out AP. Now to find AP, તમને cosine formula આવડે? Cosine formula. એવું આવું નાનું પડી તો સીધી ઉપર દે દોડ દે ના નથી આવડતી. લક્ષ્મણ સાહેબ તમને શીખવાડ્યું હોય બધું. Trigonometry માં cosine sin formula આવડે?
Yes.
Sin A by A equal to sin B by A. એવી cosine formula છે. આવડે છે? નથી આવડતી. Math for us is you are making it difficult for me. Either math ના ક્લાસમાં તો મારે એવું થાય કે ડેરિવેશન કરાવવું ન પડે. કહી દો કે ખાલી આમ કરી નાખો તો બાકીનું મેથ તો હેન્ડલ કરી લે. ન કરી લે? Come on. Okay, ચલો કઈ વાત નહીં. તો તમે ના પાડો છો cosine formula થી નથી કરવું બીજું શું. So we want to find AP. So look at this triangle that we have so far. I'm going to draw its replica over here. Okay. At right angle with you. Please don't take it that way. Okay, so this is what we have. Now here is C, here is A, and here is P. Suppose we treat them as vectors. CA vector and AP vector and CP vector. Then this angle is theta. So do you agree that AP vector is is actually equal to CP vector minus CA vector by triangle law of subtraction. Yes or no?
Yes.
Sure. How do you triangle law of subtraction? Two vectors coming out from same point, then you join the head of one with the head of the other. That means you are doing subtraction. Clear? Now, in magnitude form, there is a formula for difference. The resultant formula is R equal to under root a square plus b square plus 2ab cos theta. Just like that for difference, there is a formula a square plus b square minus 2ab cos theta. Yes or no?
Yes.
Figure it out. पूरा क्लास में पता भूल गया. अपने आवड़े है. Sure?
Yes.
Okay. So this is the difference. So under root. What should I write? What should I write? CP square. CP square means R square. Yes or no?
Yes.
Sure. Plus CA square. What is CA square? A square. And then minus 2AR cos theta. Got it? Got it or not?
Yes.
We use that difference magnitude formula. Under root a square plus b square minus 2ab cos theta, where theta is angle between vector first and second. Okay, right? Now we will do some amazing mathematics using neglecting everything. So we know that a is very small compared to r, so we neglect it. We neglect a square compared to r square. Got it? So this would be written as raised to half of r square minus 2ar cos theta. Clear? A square can you? Right. Looking up the side. A square is neglect. Fine. Clear or not clear? Okay. Now, I'm going to take r square common out of it. So r square 1 minus 2a cos theta by r. Then this raised to, the whole raised to half. Sure? This is clear to you? Confusion with it? If there is confusion, try to go reverse. You will get it. Multiply r square inside, r square into 1, r square. R square multiply here, 1 r will get cancelled, 1 r will remain. So 2ar cos it. Got it? Okay. Now we will the next step, and that is to apply the square root to r square. Therefore, AP is equal to r. Bracket 1 minus 2a cos theta by r. Now here, do you realize that a upon r is very small? Yes or no?
Yes.
Sure, because a is much smaller than r, so a upon r is very small. That is compared to 1, this second term is very small. No, we will not neglect them. Ola class my opinion of the we will do this. Do you remember this? We have learned it in gravity. It is called binomial approximation. Right? That when x is very small compared to 1, we can write 1 plus x over raised to n as approximately 1 plus n. So compare. Instead of plus, if it's minus, don't worry, you have to write minus. Then what is at n's place? N is the power. What's the power? 1 by 2. And then x is the second term. So write the second term. 2a cos theta upon r. Clear? Using this. Fine? Fine or not? बहु एक साथ एक लोग करो ने confusion नहीं तो नहीं r square square root r, and here we have used binomial here. Okay, the binomial approximation. So AP becomes, now I multiply the r inside, r into 1, r to cancel. When I multiply r inside, r also cancel. Yes or no? Yes or no? R minus a cos theta. Clear? Sure? Fine. Leave this. Now, we found it. ये हमारा मेहनत है. Physics तो हम बे लाइन में कर दे. Okay, now time to find the other distance, because if you want to find potential, you need the distance. So now time to find PP. Okay, I'll continue writing up here. So instead of drawing all this again, I'll do this. Is this clear? Okay. Clear so far? What is this angle here? It's going to be pi minus theta, or 180 degree minus theta. Yes or no?
Yes.
Okay. Pathway. Right? So if you have one vector here, CB, okay, and one vector here, CB, their subtraction is PP. Okay, EB vector equal to CP vector minus CB vector. Sorry, DC vector. CB vector. Is it fine?
Yes.
Join or subtraction case that. First of all, look at right side. CP vector going that way, and CB vector going this way. So now if you subtract CP and CB, then the arrow should point towards CP. Clear? So this is going to be BP vector. Wait a moment. This is going to be BP vector. Yeah. Fine? Yeah, so then I gave the other
Yes. Yes.
Okay, so this is BP vector. Now, we will use the same thing here. Addition of never mind. So BP equal to same procedure or not? What's the angle between CP and CB? Pi minus theta. So here look, r square plus a square minus 2ar cos pi minus theta, or 180 minus theta. Cos pi minus theta is minus cos theta. Okay, so minus plus. Fine so far. Cos pi minus theta is minus cos theta. Clear? Now we are going to do a world record holder long jump. Okay, or like 1 or similar to 1. BP is equal to. Is that clear? Yes, I do. Abadu Kairu. Is that clear or not clear? Still, our jump is nothing compared to what the authors have done in the book. તમે જોઈ લો એ લોકો કેટલા સ્ટેપમાં ઉલાળ્યો કરી નાખ્યો. Did you find it? જો I suggest that you see તમને એમ થશે આવું જ લગ્ન ખાઈ સીધું કઈ ઝંઝટ જ નહીં. મળ્યો કે નહીં ટોપિક પાછળ હશે. Here, it's on page number 56. Now by geometry, r1 square equal to r square plus a square minus 2ar cos theta. So geometry. You see how they are writing? They are hiding all the maths. Bas aave. Okay. Actually, you can do it by cosine rule also. જો તમને યાદ હોય તો ફટાફટ થઈ જાય. આનાથી ઓછા સ્ટેપ થાય. But you said you don't know, son. Anyway. Right. પછી લોકોએ શું કર્યું? કોમન કાઢી લીધું, નિગ્લેક્ટ કરી નાખ્યું અને બાયનોમિયલ થિયરમ એ નીચે લખી નાખ્યું. ઓકે? રાઈટ? You see they have used binomial theorem or not? દેખાય છે કે નહીં? મળ્યું ને? ખાલી લોકો r અંદર મલ્ટીપ્લાય નથી કરતા. અને પછી કંઈ જ લેખા વગર સીધો આન્સર આવી ગયો. હજી આપણે થોડુંક તો કરવાનું છે. We have found AP and we have found BP. Alright? What would be next step? હું તમને કહી દઉં. બાકીનું ડેરિવેશન તમારે કરવાનું. ચાલો. એક સ્ટેપ લખી દઉં. Potential at P. VP is equal to VP due to A plus VP due to B. Clear or not? How many charges will create potential at this point? Which two? The positive charge at A and the negative charge at B. તો કે રીતે કરે VP એ માં શું લખવાનું K plus Q by distance. How much is the distance? How much is the distance? This one. AP. How much is that? આવડી ગયું ને પછી સેકન્ડ માં માઈનસ Q હશે ને પછી LCM લઈને સિમ્પ્લિફાઈ કરો ને ગોટ ઇટ
Yes.
ફાઇન ઓ done this